By the end of this lesson, you should be able to apply the one-to-one property of exponential functions to solve equations. And the equations that we're going to be looking at are the exponential equations and logarithmic equations. So let's get started with our lesson. Now, what is the one-to-one property of exponential functions? You will recall that an exponential function is in the form f of x equals b to the x. And notice our exponent here is a variable. So the one-to-one property of exponential functions says, for any real number, and here our real numbers are represented with b, x, and y. For any real numbers, b, x, and y, where b is greater than 0 and b is not equal to 1, if b of x is equal to b to the y, so if b to the x is equal to b to the y, then x is equal to y. So if the bases are the same, the exponents are equal. Okay? Now let us look at how we use this to solve equations. So we're going to look at exponential equations. An exponential equation is an equation in which the unknown is in the exponent. So exponential equations look like this, and this is a basic form of an exponential equation, and this is another form of an exponential equation. So let's look at how we solve. The one-to-one property says, if the bases are the same, then the powers are equal. So can I get both sides of this equation to have the same base? Yes. You will recall that 4 can be written as 2 to the 2. So since the bases are now the same, then the exponents are equal. Now let's go to this one. My base here is 16 and I have a base of 4 here. To use the one-to-one property, if we get the bases on both sides to be the same, then we can equate the powers. So we can write 16 as 4 squared. So 16 becomes 4 squared, and all of that is still raised to this exponent, x plus 3. And that is equal to 4 raised to the 4x minus 7th power. Now, if you notice here, I have a number raised to a power, and all of that is raised to another power. The power of power property can be used to get rid of this bracket. So you'll recall, if I have a number raised to a power and all of that is raised to another power, we multiply the powers. So when this is applied, we end up with 4 to the 2x plus 6, and that would be equal to what we have on the right, 4 to the 4x minus 7. Now our base is the same on both sides. Yes. So if the bases are the same, then the exponents are equal. So since our bases are the same, our powers, our exponents are equal. So 2x plus 6 is equal to 4x minus 7. And you will remember solving equations, we try to get our variables or the unknown on one side of the equation. So let's add 7 to both sides and then subtract 2x from both sides. So we'll end up with 2x equals to 13. And because we want the x alone, we divide both sides by 2. So we end up with x is 13 over 2. Now what about this one? Can we get both sides with a base the same? Can we get both sides with the same base? So if we want to use the one-to-one property, we get both sides with the same base. So you'll remember that 1/2 can be written as 2 to the negative 1, and the 64 can be written as 2 to the 6th. So notice here we have, again, a number raised to a power, and that is raised to another power. So we can apply the power of power property here. So when we apply this property, we end up with 2 to the negative c is equals to 2 to the 3rd, because 6 times 1/2 is 3. Since our bases are the same, then the exponents will be equal. So we will end up with negative c equals to 3, but we want a positive c. So we divide both sides by negative 1. So we end up with c equals to negative 3. So again, the one-to-one property says once the bases are the same, the exponents are equal. Now, here are 2 questions for you to try. Pause the video, try the questions. Once you're finished, press play to continue. And here are your answers to the questions. Now, how did you do?
Now, before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Okay, let's move on. So we're still on solving equations, but now we'll take a look at solving logarithmic equations. Another statement that follows from the one-to-one property is if x equals to y, then I can say that b to the x is equal to b to the y. And this relationship can be used to solve logarithmic equations. Now let's look at an example. We're asked to solve the equation and round to the nearest hundredth if possible. So if we're going to be solving using the one-to-one property, then we need to convert our logarithmic equation, which is this, into an exponential form. And you will recall that logarithmic function is the inverse of the exponential function. So to convert or eliminate this logs, we use the inverse property of logarithms. So you'll remember that ln and e are inverse of each other. So to change from logarithmic form to exponential form, we introduce. So I can write e to the ln x is equal e to the 6. Now, once we put the two inverses together, once we compose the inverse, then it will go and leave us just with x. So we'll end up with x is equal to e to the 6. And if you were to put this in our calculator, the value of x is approximately 403.43. And we did 43 because it says round to the nearest hundredth. Okay? And we want to ensure that we check our answers. So we eliminate having errors written down. So be sure to always check your answers. And we check by substituting this x value back into our original equation and see if we get the number on the right. And when we checked, we did. So we are good to go. Let's look at another question. 7 minus 3 log 10x equals to 13. And remember, when we see the logs and there is no number given in the base, we assume base 10. So if we're solving the equation, the first thing we want to do is to isolate our logs. So we need to move everything from around the log. So that includes, we need to subtract 7 from both sides first. So when we subtract 7 from both sides, we end up with negative 3 log base 10 of 10x equals 6. The next thing we'd want to move is our negative 3. Now it's been multiplied, so to eliminate, we divide by 3. And we divide both sides by negative 3. When we divide by negative 3, we end up with log base 10 of 10x equals negative 2. Again, if we're going to be using the one-to-one property, we need to have exponents. So we need to convert from logarithmic form to exponential form, and we do that by using the inverse property. So if you notice here for the inverse property, and we'd have done this before, the base is the same as the value here. Okay, so remember, logarithmic form and exponential, those are inverse of each other. Logarithmic function and exponential functions are inverse of each other. So I can now write my equation as 10 log base 10 of 10x equals 10 to the negative 2. So again, once we compose the inverse, we will be left with x equals to 10 to the negative 2 on the right, and that is equal to 1 over 100. And of course, here are some questions for you to try. Pause the video and try the questions. Once you're finished, press play to continue. And here are the answers. How did you do? I hope you did okay. If not, you can always go back, watch the explanations, and try the questions again.